Great. So we are Mesophase. We are designing surfaces for energy efficiency. My name is Michael Gangemi, and I co-founded Mesophase with Dr. Yajing Zhao. She brings an incredible experience in surface design and heat transfer here from MIT. And I have a background in building and scaling technology companies. And we co-founded Mesophase really to address the water and energy challenges that we're facing today. And make no mistake, we are in the middle of a water crisis. In the next 3 years, 2/3 of the globe may be facing water shortages. And we know a huge part of this challenge is the fact that energy and industrial processes use half of the water that comes from the ground each year. And what makes matters worse is that energy and water efficiency programs at power plants like this one often actually increase operating temperatures, which can cause corrosion and reduce efficiency. So Mesophase was founded to address these trade-offs. We're commercializing technology that protects surfaces from corrosion and improves heat transfer efficiency. With better protected surfaces and better heat transfer, a power plant like the one in the background here can move from using ocean water or fresh water to using wastewater for cooling, all while reducing emissions and maintaining their output. Our technology is a patent-pending hybrid coating process. So we start with a heat exchange surface like a tube or a coil. First, we grow a metal structure which anchors our coating in place. Next, we apply a polymer which fills the gaps and repels water. The combined surface takes on the heat exchange properties of the metal, the protection of the polymer, and it's more durable than either of the layers alone. The most obvious application for this kind of technology is in heat exchangers. And for those of you who don't know, heat exchangers are everywhere. Roughly $20 billion of them are sold each year across a huge variety of industries and applications. And an opportunity for us is the fact that heat exchanger technology really hasn't changed very much in the last 30 years, despite the complaints that we often hear from engineers about inefficient or finicky or just misbehaving units. And inexpensive coatings have been developed in the past to help address these problems. But because they aren't durable, engineers prefer to just pay more for expensive alloys or chemical water treatments. Our coating was designed to outcompete these other technologies by lasting longer than other coatings and delivering efficiency benefits. And in the long run, we want to see our technology applied to every heat exchange surface that rolls off a manufacturing line. But to get there, we know that we'll need to prove that it works in a real plant. And so today I'm excited to announce that Shell recently approached us to launch a pilot in a plant to test corrosion and fouling capabilities, which we know are multi-billion-dollar problems for them each year. They typically run heat exchangers in banks in parallel so that they can take units offline and repair them when they corrode or foul. They're excited to work with us to pilot the technology and help address this huge problem. And this is really one example of the type of partnership that we're looking to build. So as I mentioned today, the technology has been tested and demonstrated to dramatically improve heat transfer and corrosion protection at lab scale. And we're looking for partners to help develop the technology further and prove that it can be manufactured at scale and that it performs in the field. So if you're interested in learning more or exploring a collaboration with us, please come find us in the breakout room or reach out to us after the show. Thank you very much.
Thank you, Michael. So again, a reminder to post your questions in the chat. The first question is there anything else out in the market that you can speak to?
Yeah, so we've seen kind of simple polymer coatings and epoxies and resins used in similar applications. I think, as I mentioned, the issue that polymers typically run into is durability constraints or application constraints. So this technology was really designed to address the durability problems that are kind of inherent in using a polymer for either protection or efficiency purposes.
Okay, and can you talk a little bit about Mesophase and how that comes into play with your technology?
The story here, I guess, is that we're inspired by Mesophase as a surface technology in nature. So it's obviously not in use here, but just an inspiration for us to improve efficiency in a plant as nature does.
Okay, thank you. And if you have any other questions for Michael later, you can definitely post them in the chat. We will move now on to the fourth startup. We have Grant Gunnison from Zero.